Live from the BBC, The Naked Scientists.
This week, it's the Naked Scientist Science Phone-In, and that means that for the next hour, we'll be taking any questions that you send us via text, email or phone, and we'll be answering them live on the programme. If you want to get in touch with us, 08459 25 2000's the phone number, or you can email me, chris@nakedscientist.com. Hello, I'm Chris Smith, and also here to help present tonight's programme is Dr. Kat and Dr. Phil. Hi, you guys.
Hello.
What else have we got in store for everyone tonight?
OK, also tonight, we've got the latest science news, we've got erasable tattoos and glow-in-the-dark motorbikes, along with sex and death in spiders, and the fact that passive smoking may actually not have more effect than just your health. Also, we've got formation flying satellites and the closest passing comet in the past 20 years.
That sounds fantastic. Now, we'll also be having Kitchen Science, and Anna, Wendy, George and Tom are at the King's School. And if you want to join in with Naked Science tonight, I strongly suggest the wine glass that you're drinking out of now, down the wine, fill it with water and stay tuned because you're going to be needing it later. We have prizes tonight. You can win all sorts of things from our big prize bag if you're the first person in with the correct answer for Kitchen Science. And also you can win prizes for our competition.
The Naked Scientist Podcast, brought to you by thenakedscientist.com.
Well, let's kick off with a look at what's been happening elsewhere around the world this week from the world of science. And this is going to be a real blast from the Wehey Eureka League people for anyone that's had a tattoo and then regretted it later, because there's a guy over in America at the Massachusetts General Hospital. He's a dermatologist called Rox Anderson, and he's come up with the erasable tattoo. So if in a fit of passion you had Sharon Forever emblazoned across your forehead, and then had sort of second thoughts later, or perhaps Sharon became Sherin, or perhaps even Kevin, now there's help at hand, because if that happens in future, you can use this new technology that Rox Anderson has come up with to wipe the slate clean and start afresh. Turn over a new leaf, if you like. Perhaps if you had an ivy leaf on your hand or something, you can get rid of it. Now, how does it work? Well, what this guy has done is to find a way to lock away the pigments that you normally have injected into the skin to make a tattoo inside tiny beads, and these beads are about 3,000th of a millimetre across. They're very, very small. They're made of a special polymer, and you inject them into the skin in the same way you would a normal tattoo, but then the cells in the dermis, the lower layer of the skin, pick up those tiny capsules and store them inside the cell, and at the same time the cell then takes on the colour of its new cargo. Well, how do you get rid of them? Well, that's simple too. You just swipe a laser over the area, and the laser blasts apart the tiny capsules, releasing the cargo they carry, and the cell then breaks it down and gets rid of it. It gets washed away, and the tattoo's gone. And that's a vast improvement over present techniques, because if you have a tattoo done the standard way, it can take 10 treatments with a laser, and it only gets rid of it 50% of the time, and it's painful too. So this looks like a major step forward, and I think probably a lot of parents are quite relieved too. Have you got a tattoo?
It says, "I love Dr. Chris." It's tattooed on my arse.
On your arm?
Arm. That's what I said.
I thought that's what you said.
Yes. Anyway, here's a tale of sex and death in spiders. So there's many animals in the world that play dead, and this is as a way of avoiding being eaten. But there's a certain type of spider which is called the nuptial gift-giving spider. If you want the Latin name, here goes: Pisora mirabilis. Mirabilis, maybe.
The Queen had one of those, didn't she?
She did.
That was Isaac Newton. And he had an Annus mirabilis when he discovered gravitation and all that kind of thing.
A queen had an Annus horribilis. Anyway, these spiders, the males are quite small. And there's quite a risk when they're attempting to mate with the females that they get eaten before they've done the deed, as it were. And they've discovered that these spiders get round it by bringing presents for the female spiders. So this is the equivalent of turning up with a box of chocolates or something for your lady. They turn up with a box of chocolates, and the lady spider goes, "Ooh!" starts eating the spider presents.
But what are these presents? What do they turn up
They're
with?
little bits of food, basically. So
Like other spiders, dead spiders.
they're little bits of spider food. And the male turns up with the food and sort of says, "Here, darling." The female spider starts eating it. And at that point, the male spider plays dead. So he looks dead already, so the female's not going to eat him. And while she's enjoying the food, he slips it, you know. He has a go at mating with her.
Yeah, I was just thinking, because that really is kind of diversionary tactics, isn't it?
Exactly. He plays dead while she's eating the nice, box of spider chocolates. And so he gets to mate with her while she's distracted.
That really is food for thought, because they normally say that way to a man's heart is through his stomach, but it looks like that's wrong. It should be the way to a female's heart.
Yeah, if you're a male spider listening to the show, that's the way to do it.
Now, also, in the Massachusetts Institute of Technology, they've just invented, or they've just actually launched, a new type of mini satellite, and they're called spheres. Now, it's a little bit misleading because they're not actually spheres. They're actually 18-sided, which means they're octodecagons. But they're close to sphere. They're about the size of a football, a bit smaller than a football. And they've actually been launched up onto the International Space Station. The idea being they can test them in microgravity, actually inside the space station, so that they can be fiddled around with by the astronauts on there without having to go actually out into the vacuum of space.
What are they going to do, Phil?
Now, the idea of these things is that they're going to be formation flyers. They sort of hover, they've got little battery packs, actually powered by 16 AA batteries, and they've got a little carbon dioxide thruster on them as well. And the idea is that they can hover in formation. They ping each other with ultrasound beams to find out where each other are, and they communicate with a laptop via radio frequencies. And the idea is they can hover in formation, and it's a build-up in the idea to technology that we can actually create a giant telescope in space, where possibly all the little bits of the mirror could be held in place by mini satellites in their own right, and then they can reflect all the light to one other satellite in the centre, which would be a detector.
And they can sort of move around to refocus or move targets or whatever they want.
Absolutely correct. I mean, it could be all sorts of things like this. They could even be out there helping astronauts on spacewalks.
I'm slightly concerned that they're battery-powered. Are they going to get up to the shuttle and the astronauts are going to go, hang on, did you bring the batteries?
Who packed the batteries?
Mum!
Hopefully they should have a plentiful supply of spares. That's the whole idea, that they get on there and they can be re-battery packed and the carbon dioxide cells can be filled up, all without actually having to go out into the vacuum of space.
It's the Naked Scientists, Chris, Phil and Kat, and it's your chance to join in our Naked Scientist Science phone-in this evening. The phone number's 08459 25 2000. The email address, chris@nakedscientist.com, and if you'd like to send us a text message, it's 07786 20 1960. That's 07786 20 1960. Any science question that tickles your fancy, we'll have a go at it. Right, now, who's got a motorbike? You're far too sensible to drive a motorbike.
No.
Phil?
My mum told me I wasn't allowed because my uncle broke his collarbone on one.
I have a motorbike in the garage. It's not been on the road. I rebuilt it from bits and pieces a long time ago.
Is it made of Lego?
Just drive it around the garden. No, it's actually an MZ, which is sort of the motorbike equivalent of a Lada, I think is safe to say. So you wouldn't really drive that on the road unless you wanted to escape without your credit intact. But anyway, a much better class of motorbike is a Yamaha, of course, as the Japanese make, and they've come up with an ingenious way to make motorbikes safer at night, because of course other motorists seeing motorbikes is the cause of most motorcycle crashes. It's us not being aware of people on their bikes coming along. So they've come up with what I suppose you could cunningly call a gloater bike. Essentially, they've got this dye which you can spray onto various areas on the motorbike, uneven surfaces like the fairings, the manifold, the engine, and it glows in the dark, this dye. And this means it soaks up UV light from the sun during the day. It's like a giant energy sponge. And in the actual pigment itself, the electrons whizzing around in the molecules get zipped up to a higher energy level by ultraviolet light from the sun. And then they stay in that form until night time, and then they begin to gently drop down to their normal energy level, and when they do so, they give out some light, and so these motorbikes emit this soft glow at night time, which means that rather than you just seeing, say, one headlight or one person with a glow-in-the-dark strip across them, you see a much bigger moving object. And that makes them much easier to see, because the problem with a motorbike is it doesn't really subtend much movement on your retina, so it doesn't make a big impact on your visual scene, so you're much less likely to see it. So if you make something that's big and bright out of something much smaller, you're much more likely to see it, and therefore much less likely to have a crash.
That sounds really blingy. You need something like, those UV lights underneath it, like you see under those cars in the marketplace, because that's really cool. Anyway, here's a story about smoking. I'm quite interested by this one. Maybe we could discuss it afterwards. And it's a study of passive smoking that was done in Cincinnati in America. And the researchers studied over 200 children and young people, sort of pre-teenage, for the effect of passive smoking. And passive smoking is known to affect children by giving them asthma and things like that. But it also found that children who were exposed to cigarette smoke during the day, who weren't smokers themselves, had sort of behavioural issues as well. They sort of had anxiety and depression, behavioural problems at school, and learning problems. And so it's quite interesting as to whether this is some sort of social effect, whether the kind of children that are exposed to cigarette smoke are in some kind of social environment that predisposes them to be like this, or whether it is actually the cigarettes having an effect. In a study in 2002, the same doctors found that exposing children to cigarette smoke could actually decrease their brain function, including their skills at reading, maths, logic and reasoning. So maybe this is another good reason that the UK is going smoke-free next year.
I think there was also a study done in a school it may have been Suffolk, I believe, where for a few days they banned pop and all other junk food and replaced it with mineral water and things like that. And the teachers reported a considerable improvement in behaviour, attention and the way in which the kids engaged in the lessons. So I think at that school they were saying they're all very much in favour of getting rid of junk food. And if what you're saying is true as well, then that may see kids improving their behaviour even more. Phil?
OK, also I'm going to talk to you about May the 12th, date for your diary. We're actually going to have the closest pass to Earth of a comet for the past 20 years.
Can we see it? Can we see it?
You can indeed see it.
Hey!
It's still quite a way away. It's actually out further than the moon from the Earth, but still pretty darn close. But don't worry about it hitting the Earth or anything scary like that. But hopefully, if you go out somewhere really dark, you should be able to see it. It's going to be just on the limit, though, of possibly seeing, possibly not. But if you get a decent pair of binoculars or something like that, you should easily be able to spot it with a pair of binoculars.
Where do we look?
You want to look now, the constellation it's in, the nearest constellation is the constellation of Cygnus, the Swan. Now, it's actually going to rise on May the 12th, sort of northeast. It'll be about northeast when it starts getting dark. And as the night progresses, it's going to get higher and higher in the sky, so closer and closer to straight up. And by about midnight, it'll be nearly straight up, just slightly over towards the east. So if you can find somewhere really dark, if you live out in the countryside, that's absolutely perfect. Get a pair of binoculars, something like that, and go have a look and see if you can spot it. We might also actually, the same night, if we're lucky, again, a lot of luck needs to be done in this sort of thing, but we might also actually get a meteor shower. So if you can just get out, have a look for the shooting stars that might be bits of dust that have fallen off the comet and be burning up as they enter the Earth's atmosphere. So everyone, just get out, have a quick look, you never know, you might be able to spot it.
The Naked Scientists. Supported by the Wellcome Trust.
Got an email here from Frank Perella, who is a heavy equipment operator in Massachusetts in the USA, and he says he downloads our show every week over there, and when he gets home he talks about it with his kids, Megan and Frankie. And he says, I usually get them to listen. I sometimes even get some of my co-workers to listen. In your show you've managed to cover some intriguing subjects in considerable depth and present them in a way that appeals to people in backgrounds. Your show is a quality production. Kudos. And he, alongside him, a number of people have said they really like our experiments. And speaking of which, it's time now to join Anna Lacey out at King's School in Ely. She's with George, Tom and Wendy, and this is where you need to get your wine glass. So if you have a wine glass and a drop of water, that's all you need to take part in this week's experiment. We want you to have a go alongside us. First person through on the phone is going to win a fantastic prize. We have to give away tonight Living Science. I think it's probably the best science book to come out this year. It's printed by Oxford University Press, and it's about the science of everyday life. Anna, what have you got?
Hi there, yes, and welcome to Ely, where this week we're at the King's School, and we're going to be doing some really amazing experiments with some music, and obviously a lot of science mixed in there for good measure, because that's what we're all about. And this week we've got our helper Wendy, and Wendy, what are you doing here today?
Well, we're going to do some experiments today about resonance and about vibrations, but using a couple of very simple kitchen props.
So you heard it here. We need you to get your equipment out, so you want to be listening very, very carefully because it involves things you have in your kitchen. But first, we're going to speak to some of our student helpers. Do you want to tell us your names and your ages, please?
Hi, I'm George and I'm 13.
Hi, George. And yourself?
Hi, I'm Tom and I'm 13.
And what's your favourite thing about science, Tom?
I like the practicals.
And you, George, are you a practical man or a theory man or...?
I like practicals, especially burning stuff.
Good answer. So, Wendy, what is it that people are going to need to get hold of from their kitchens today?
Well, all they're going to need to join in, if they want to try this experiment out, is just a wine glass, OK?
Just a wine glass. Well, that's easy. So go out there now, find a wine glass. Can it just be any... It just has to be a glass, not plastic, I take it?
Yeah, that's right. It's quite good if it's fairly thin glass, nothing too chunky. And you do need access to some sort of liquid as well. Water will be fine.
OK, so, right, now we've got our glass here, and what do you want George and Tom to do with it here?
Right, George, maybe you could just fill up the glass for us. It's about 3/4 full.
OK, George is just filling up the wine glass here. He's, OK, I think it's almost about right. Looking good.
And if you just want to pass that to me, that's great. I'm going to hold on to that. Now, what we're going to do is use the wine glass as a musical instrument. And there's a very famous experiment some people might have heard of where an opera singer sings a note and actually makes the glass shatter. I wish I had a good enough voice to do that, but I can't. So we're going to play the wine glass in a slightly different way.
OK, so are you going to get Tom to play the wine glass here?
I can do, and give him a quick lesson. I'm putting the wine glass just down on the table to give it a bit of stability. And to play it, Tom, what you need to do is put one hand on the base just to keep it steady. Dip a finger from your other hand in the water and then just rub it around the rim of the glass, OK? Don't press too hard, just rest your finger on the rim and rub it around.
OK, so this is one of those well-known party tricks where you play the wine glass, and Tom's going to try it now.
Oh, I can hear it. It's coming. Press down a little bit harder. There we have it. And when you're very close up, you can actually see some of the vibrations on the water too.
OK, well done, Tom. That was really, really great. Now, so what's the next part of the experiment? I mean, obviously, we don't just want to play a tune with one note. I mean, how can we change it?
Yeah, music would be pretty dull if we only had one note to listen to. So what we're going to do is change the glass. We're going to set people a challenge to see if they can predict scientifically what they think is going to happen. So it's a very simple change we're going to make. All I'm going to do is I'm going to drink about half of the water out of the glass, and I want people to think about what will happen to the notes.
OK, so while Wendy glugs away at some of the water out of that wine glass, I'm going to ask, so, George, what do you think will happen to the note now that Wendy has drunk some of the water?
I think the pitch will change, but I'm not sure which way.
You're not sure which way? Well, that's a good prediction. I mean, Tom, do you have any ideas about whether the note will get higher or lower?
I think the note will probably be higher.
And why do you think it will be higher?
I'm not sure, but I've just got a feeling that it might be.
Well, we will see exactly what happens to the note. But, well, that's it. Wendy has now finished her drink. But we're not actually going to be finding out right now. We're going to get George and Tom to wait here in their school, at the King's School in Ely, before we find out exactly what happens. But until then, we want you to get hold of a wine glass, get hold of some water, dip your finger in it, make the sound, drink half of it, and then make the sound again. And then tell us what happens. And once you know the answer, you can call us on 08459 25 2000 or email your answer to chris@thenakedscientist.com, and you can win a prize. So all very exciting, all very easy. And we'll be back later in the show. So until then, back to the studio.
Thanks, Anna. The Naked Scientists, and it's Chris, Kat and Phil, and we're taking your science questions because it's the Naked Scientists Science Phone-In. If you'd like to join in on the programme tonight, 08459 25 2000. You can send us a text message, which is 07786 20 1960, or, of course, email me, chris@nakedscientist.com.
Sorting out the sparks from the quarks. The Naked Scientists.
Right now, we need to talk to Alfred, who's in Norwich. Good evening, Alfred. Alfred, how are you?
Yep, quite good, thank you.
Thank you for joining us. What would you like to talk about?
Yes, well, we know that we're living on a kind of nuclear furnace, and heat's being made all the time in the core.
In the Earth? In the centre of the Earth?
In the centre of the Earth, yeah. Is there no way we could kind of harness this heat in the future, do you think?
It already is, Alfred.
Is it?
Yeah, absolutely.
This is why Iceland's actually one of the major producers of bananas. Did you know that?
No, I didn't know that.
A lot of bananas come from Iceland because it's a centre of geothermal activity. It's areas in the on the Earth's surface where the heat from inside actually heats up things like water. So you get these very hot geysers, very hot rocks and areas of the Earth. And you can harness that heat. And in Iceland, they use it to power their greenhouses for growing bananas. And in other parts of the world as well, there is geothermal heat being used to generate
energy.
In
New Zealand, North Island, near Rotorua, which the downside is that the whole place smells of rotten eggs because there's a lot of sulphurous gases coming out of the centre of the Earth there too. But yes, as Kat says, it's already used, and the way in which you do it is you pump water deep down to where the rocks are hot enough, and the water comes up at obviously very high temperature, very high pressure, and you can then either send that water off as a direct distribution, or you can pass it through a heat exchanger and then distribute that heat around houses, hospitals, and other places that need energy. It's great for bathing in too. So it's already done, Alfred, and where it's possible to do it, in other words, where there's hot enough rocks close enough to the surface to make it cheap enough, in other words, economical to get to them, they do it.
I see. Why don't they kind of like, I know I did hear of where they can actually lay pipes to a certain depth, and the water can be heated that would supply to, to houses and that. So these new estates, surely they can be built as they're building the new estates. They could lay these pipes down.
Yeah, you're thinking of combined heat and power, actually, and that's also been tested. And there are a number of new installations, I think, being plumbed in now because people know the importance of doing this. What you do is build a power station somewhere, and it produces electricity, of course. A waste product of a power station is heat. That's inevitable because of the inefficiency in the system. And so what scientists can do is to collect some of that waste heat, warm up the water from it, and then it's distributed, as you say, in a big circular pipework around local housing so that people then have their heating costs for nothing. And the reason that it's good to do that is because every time you turn one form of energy into another, you waste some energy. So plugging in your electric kettle you've already burned coal to make electricity, and then using that electricity to make hot water is again a bit inefficient. So if you can just have some hot water straight away, you've saved a step in the conversion, and that saves some energy and improve the efficiency.
Yes, but why don't they get on with it and if they can build in these new thousands of houses, then why isn't it...
Well, the slight snag is you have to balance out the good for the environment with the bad for the environment, because if you were to just suddenly convert the whole country to doing this, you'd have to knock down all the existing power stations and build new ones, and it costs a lot of energy to build a power station, and so you've got to balance out the lifetime of an object against the cost to the environment of building a new one and the benefit to the environment of plumbing in all these other things. So that's really what people are going to be thinking about in the future. Do you want to have a quick go at the quiz?
Yes.
Okie dokie, here we go. Pluto takes 248 years to go around the Sun once. Do you think that's fact or fiction?
How many years did you say?
248. Fact or fiction?
To go around the Sun. 248 years?
That's right, yeah.
Oh, no, it'd take much longer than that.
It is actually true. Pluto's way out there, 5,000 million kilometres from the Sun, and it takes 248 Earth years to go round it once.
The average person has 50,000 hairs on their head, Alfred. Is that fact or fiction, do you think?
50,000? I would say it'd be more than that.
So you're saying false, yeah?
Yeah.
You're absolutely true. It is more than that. In fact, it's about double on average, 100,000.
Right.
Well done. That's 1 mark. And a cockroach can survive for several weeks without its head, Alfred. Is that true or false?
I would say true.
Rather grotesquely, you're right. In fact, it will survive, but it starves to death in the end because it can't eat.
Yeah.
Alfred, thanks very much for your call.
Yeah, thanks.
Take care.
Yeah.
You're listening to The Naked Scientists, Chris, Phil and Kat, and if you'd like to ask us any question about anything science, just call now 08459 25 2000, or you can email chris@nakedscientist.com. We do take texts as well. The text number's 07786 20 1960. Gordon is in Huntingdon. Hello, Gordon.
Yes, good evening.
Good evening. Thank you for joining us. What would you like to talk about?
I'm curious about this digital signal sort of era we've gone into.
Mm-hmm.
Basically, if you watch the television on digital signal, the clock that they show, especially on breakfast television, is slightly different time than actual real time, because, the signal going up to the satellite and coming back down again. And I wonder, is there a way of solving this?
Well, there is actually, and they rely on Einstein's special theory of relativity to get around the problem with things like GPS.
Right.
But not really, because it's going to be slightly different for everybody depending upon how far the signals had to travel. So, in actual fact, it's quite difficult. The only way around it is to provide local time signatures.
And they're going to switch off the analogue signal, so it's going to cease to be an issue. And we'll all be slightly out of time, I think, in the future.
Right. Well,
maybe by a second.
Even if they do switch off the analogue signal, that differential is still going to be there, isn't it?
Presumably, yes. So,
the thing is, if you ring up for the time on the phone, you get an accurate time check, but the TV will be different.
It could be, yeah. But the thing is that to the average person, where we live in a world where most people's watches are out by several minutes relative to Greenwich Mean Time, the fraction of a second disparity on the television is probably not going to affect most people's lives, if I'm being really honest, Gordon.
Right. Couldn't they sort of, the TV people, couldn't they set the clock slightly different time to say it's correct when we receive the signal?
Trouble is, it might be correct for you, but what about if you're watching it in Spain?
Right.
And then it's going to be wrong for them.
Right.
So it doesn't actually really help.
Right.
Do you want to have a quick go at the quiz?
I'll have a try, yes.
Swimming pool chemicals can turn your hair green. Fact or fiction?
Fiction.
Unfortunately, it's true. According to hairboutique.com, frequent swimmers with natural blonde or chemically highlighted hair
can
actually get the green tint to the hair over time.
Right. Okay.
Next question, you ready?
Yes, I'll try.
The Earth's magnetic field flips twice every year at the time of the solstices. Is that fact or fiction?
I think that'd be fact.
No, it's not the magnetic field. The Earth's magnetic field does indeed flip round, but only every few 100,000 years. And the last time this happened was 750,000 BC. Apparently, it may happen in the future, but there wasn't any obvious effect on life on Earth.
So you could say we're sort of overdue for it to happen again. In fact, the Earth's magnetic field is decaying away, and there will be a period in a few thousand years' time when there isn't one, and this anomaly, I think, Phil, you can probably tell me, is causing satellites to have a bit of problem over an area of the South Atlantic. There's this is allowing cosmic radiation to penetrate further into the Earth's sort of space than it would do normally, and this cosmic radiation is damaging some satellites and certainly damaging communications in that area.
Absolutely. The weaker the magnetic field is, the more stuff can actually get through the magnetic field onto the Earth, so that can cause all sorts of problems with communication, things like that.
And your last question, Gordon.
Yeah.
Jupiter's giant red spot is caused by an enormous volcano that's spewing out clouds of dust containing iron oxide, which is what gives the spot its red colour. Do you think that's fact or fiction?
I think that's fiction.
You're absolutely correct. In fact, the red spot in Jupiter is actually a giant storm in the atmosphere.
Right.
And that storm's actually twice as big as the Earth itself, so a pretty impressively sized storm, actually.
Yes. This question I asked was for a colleague of mine, and he's on holiday at the moment in County Durham. I wondered, could I pick up the programme at a later date on the computer?
You can do, and the way to do that is to go to nakedscientist.com/podcast. And if you go there, it'll give you instructions on the screen as to how you can grab it.
Right.
All right, thank you for joining us on the programme. It's been great to have your company.
Yes, thanks very much. Bye-bye.
The Naked Scientists, Chris, Phil and Kat, and if you'd like to join in the show, any science question on anything, 08459 25 2000, or you can email chris@nakedscientist.com. Quick hello to Selene, who's in Hong Kong. She says she's a biology teacher listening in the Far East, as is Christopher Gallagher, who's working as a researcher and also enjoys other science programmes. He's in Hong Kong too.
So now we're going to hop across the pond and have our science update from Chelsea Wald and Bob Hirsch, who are from the AAAS, the American Association of Science. And this week we're going to find out how elephants are solving the oil crisis and also meet the woman who never forgets, rather scarily. But first, it's time to find out the answer to the riddle that Chelsea set us last week.
This week for the Naked Scientists, we're starting off by answering last week's riddle. Bob, pray tell, what is brown, sounds like a bell, and could help solve the oil crisis?
Elephant dung. Yes, that's right, elephant dung. Now, you may ask, how is elephant dung going to solve the oil crisis? Well, you see, ethanol from plants like corn is a promising alternative fuel. And now, scientists in the Netherlands have developed a more efficient way to produce it using a gene from a fungus found in elephant dung. Industrial microbiologist Han van Maris of the Delft University of Technology explains that baker's yeast can convert plant sugars into ethanol, but couldn't metabolize the indigestible wood sugars until now.
By taking this gene from the fungus we isolated from the elephant dung and putting it into baker's yeast, we have created a yeast strain that, under laboratory conditions, can produce almost twice the amount of ethanol from plant biomass as a normal yeast strain would do.
He says that because elephants eat so much roughage, their digestive tracts are full of microorganisms that can tackle the tougher sugars.
Ew. Well, next we have a fascinating case study. We hear a lot about patients who lose their memory either due to an accident or a disease like Alzheimer's. But here's a patient with an abnormally good memory.
Do you remember what you did yesterday? Well, how about May 10th, 1996? For a 40-year-old woman known as AJ, these questions are equally easy. Psychiatrist James McGaugh of the University of California at Irvine has been studying her previously undocumented supermemory. For example, given no advance warning, she was able to rattle off the dates of Easter for the past 20 years.
And she is Jewish and would have no specific reason to pay attention to Easters, but without any effort at all, she immediately gave us the dates. She made a mistake by 2 days and then quickly corrected it, and she also told us what she was doing on each of those days, which we verified by turning to a diary that she had kept over the years.
Remarkably, he says AJ doesn't rely on rote memorization or mnemonic devices. She just vividly recalls each day as if it were yesterday. His team plans to use brain scans to find out if her memory is organized differently than other people's.
That's all for this week. Next time, we'll talk about the latest things neurologists are saying about keeping your brain happy and healthy. Until then, I'm Chelsea Wald.
And I'm Bob Hirschon for AAAS, the Science Society. Back to you, Naked Scientists.
And thanks to Chelsea and Bob. You can find out more of their science updates and more info about these stories on the website they have, which is www.scienceupdate.com.
Stripping down science.
Okay, let's do it.
The Naked Scientists.
If you've got a science question for us, 08459 25 2000 is our phone number, or email me, chris@nakedscientist.com. Jill's got in touch. She's in Cambridge. She says she's been blind for 40 years, and when she dreams, she says she can still see. She can see things she hasn't seen, like her grandchildren, and places she's been to, and how is this possible, she wonders. Well, the reason for this is that actually humans are incredibly visual creatures. We devote over a third of our brain power just to being able to see, and that makes us quite similar to dogs. Dogs, of course, don't live in such a visual world. They live in more of a smelly world because over a third of their brain is devoted to being able to smell things. In fact, a dog's nose is about 300,000 times more powerful than a human's nose.
I think my dog's 3,000 times more smelly than a human as well.
Same goes for you, Kat, but there you are. The thing about how the brain works is that when you go to sleep and have a dream, the regions of the brain that you use during the day to do various tasks, if you brain scan or look at how the brain is working in people when they're asleep and dreaming, those same brain regions light up during a dream. And so if you look at people who are dreaming and you look at the visual areas of the brain right at the back of your head, you'll see they're becoming very, very active. And when you wake people up when they're showing those signs and ask them what was happening, they'll say, well, I was in a field or I was walking around and I was experiencing something. And they can give you a pretty graphic description. Now, when you're blind, often what happens is if you've seen once, your brain and those bits of the brain that used to do the seeing have laid down a pretty powerful memory of what's out there in the world around you, and you know what colours that there are, you know what sort of objects look like. And so when you go to sleep, those brain regions, although there's no direct input from the eyes now, still can generate those images, and they're every bit as real as they were when you really were seeing. And I have a lot of blind friends who say to me they actually love going to sleep because it reminds them of what seeing is like, and it also reminds them of what colours are like, because they can really reappreciate colour. Kat.
Oh, that's really sweet, actually. Anyway, we've just got a little email here from Jeremy in mountainous Switzerland, and he says that he just wants to share his great appreciation for the show and the work of the Naked Scientist. He only found our site 10 days ago. That's www.nakedscientist.com. And he's already listened and laughed his way through 15 to 20 of our podcasts. That's pretty good going in 10 days. And he says, keep up the good work, with or without the smelly feet jokes. This must be science fiction. Yes, it is. I do not have smelly feet.
Now, what's your memory like? Because one thing that people often say is, Chris, how do you manage to remember all these scientific facts? And the answer is that I just have to read them and they sort of stick somewhere. But now to tell us how to all have an incredibly good memory and possibly even a photographic memory, and in fact one of the prizes we're going to give away tonight is the book that this guy's written, Mind Performance Hacks. That's Ron Hale-Evans from the US. Hello, Ron.
Hi, Dr. Chris. Thanks for having me on the show.
Great to have you with us. Come on then, tell us about your book. What's it all about?
Well, it's about improving not just your memory, but also things like creativity and just general mental fitness by using clever tricks, or what we call hacks.
This is not just a sort of glorified self-help book. These things actually work, do they?
Yes, I think so. Some of them are thousands of years old and are time-tested, and others are very new, using the newest cognitive research.
And have you yourself got a photographic memory?
No, I don't have a photographic memory, but I do. In fact, I have rather a poor memory at times, but I use some of these hacks to improve my memory, and I'm able to do things like I would normally be able to do, such as go to the grocery and not have to use a grocery list.
Okay. Are these things that you've worked out for yourself? In other words, are they only going to work on you? Or if people read your book and apply these things, are you reasonably confident that they're going to work for everybody?
Well, there are 75 different hacks in the book, and not every hack in the book will work for every person. But, I think there's something in the book for everyone, and everyone will find something that they can use.
Okay, do you want to talk us through a couple of them? Because I know you've got a couple in mind that you were going to tell us about.
Sure. Well, I was talking with the grocery list a minute ago, and just as you were mentioning early in the show, the human brain is incredibly visual. our distant ancestors didn't use abstract numbers or other abstract information, but they could certainly visualize concrete shapes of things, predators, food, that kind of thing. So you can use that ability that you've inherited from your ancestors to process sensory information by turning a numbered list, like a shopping list, into concrete shapes that you can remember.
So you just sort of visualize what you want to remember, see it as a thing linked to something else in your mind, and it makes it easier to remember.
That's right. So
come on then, give us an example of how you would do that for a few objects then.
Sure, okay. So let's say you have three items you're trying to remember.
Yeah.
And you associate the number 1 with a pencil because it's shaped like a pencil, and the number 2 with a swan because it's shaped like a swan, and the number 3 with a heart because it's shaped like the top of a heart. So let's say you want to remember the items bread, milk, and soup that you want to get at the grocery. You might imagine for the first item, instead of a pencil, you're using a loaf of French bread to write a letter to someone. You might imagine a milk-white swan swimming in a lake of milk.
But you've still got to remember all these things, Ron.
Well, that's true, but you're sort of relying on information that's already in your brain, like shapes, to remember things that you're trying to remember sort of on the fly, like grocery lists.
The one thing I really liked, actually, Ron, was your method for learning Morse code, because as someone that used to be very interested in radio myself, I found Morse code, and I have a very good memory, and I found Morse code impenetrable for some reason. So what's your answer there?
Well, we took a hack that was described by the children of Frank Gilbreth, who was an efficiency expert at the turn of the 20th century, who came up with a way of remembering Morse code letters by using English words. So, for example, the Morse code letter A, which is da or dot dash, is remembered by the letters, the word about. So, da about. And then B is da dit boisterously. Now,
so you're using the letters as sort of a word pattern, a rhythmic pattern.
Mm-hmm. Well, you're using the stress of the words.
So can you remember the whole of the Morse code?
Yeah, pretty much. Occasionally I have to go back to the book to refresh my memory on one or two, because I don't have that much occasion to use Morse code in ordinary life. But
maybe not.
What's dot dot dash dash dot dot, Ron?
Oh,
you can't get that one wrong. It's SOS.
Yeah. And I had one.
Go ahead.
I had one final question. And did different people obviously have different ways of remembering things? Because I can remember facts, but I just can't remember people. Have you got a quick tip for me to remember people?
Well, there isn't one in the book, but I can tell you that a good way to do it is to remember the.
He's forgotten.
The person with an image.
Okay, so I have to associate them with something that's very familiar. So what would you
associate with cat? I would associate a pair of smelly socks with cat, but that's just me. Ron, look, it's been great having you on the programme, and thanks for joining us to talk about your book.
Okay, thanks so much.
Thank you. Ron Hale-Evans has written his book. It's called Mind Performance Hacks. It's published by O'Reilly Press. We have a copy to give away as a prize here on The Naked Scientist, and you just have to ring in and take part in our competition, or the other thing you can do is to have a go at our kitchen science experiment this week. Anna's out at King's School with George, Tom and Wendy, and they're running their fingers around the rims of wine glasses. Let's catch up with Anna and just remind you as to how to do this experiment. Anna.
Yeah, hi there. I'm at the King's School in Ely, and we've been doing some really cool experiments with music here. So just to give you a little recap of what to do if you want to take part in this at home, you just need to go out and raid a cupboard somewhere and get hold of a wine glass, and that's a proper wine glass that you need here. And then you need to fill it up with water, about 3/4 full. That should be enough. And then what you need to do is dip your finger into the water and run it round the rim of the glass. Now, this, if you've done it right, should make some kind of hummy, singy sound. Now, what you need to do next is either drink or tip out most of the water, leave a centimetre or two in the bottom, and then do the same experiment again, running your finger around the rim of the glass. Now, what we want you to do is to tell us whether the second time you play the glass, when it's got less water in it, is the note higher or lower. When you've found that out, we want you to call in and give us the result, because you may win a prize. The number is 08459 25 2000, or you can email us the result on chris@thenakedscientist.com. So, I'll be here at the King's School in Ely with George and Tom, waiting to do the experiment, and we'll be back with you at the end of the show. Back to the studio.
And that was Anna, so I hope everyone's out there glugging their wine glasses for Britain, or for wherever you are in the world.
You can win yourself a copy of Living Science from Oxford University Press, which in our view is one of the best science books about the science of everyday life, a bit like what we do here on The Naked Scientist, that I think has come out this year. We got a copy to give away to you for free if you win our competition, or win Kitchen Science Tonight.
Yeah, so get calling in 08459 25 2000 with Kitchen Science or any of your science questions that you've got. We'll be coming to some more later. Anyway, so I don't know if you remember, but 3 weeks ago here on The Naked Scientists, we had Alex Hill from the London Weather Centre who talked about how to predict the weather. And the prize winners, this amazing prize, were Richard Fusniak and his granddaughter Jasmine. So they went down to the London Weather Centre and learned how to do their own weather report. So here's making her radio debut and braving the winds of London is 10-year-old Jasmine.
Hello, I'm Jasmine Watts from Cambridge, broadcasting from London Weather Centre. Here is the forecast for today for the south of England. Here in London it will be a cloudy afternoon. The temperatures will be 30 Celsius and 55 Fahrenheit. This weather will be warmer than yesterday, and the rainy showers will be mostly in the Midlands later today. That's today's weather, and back to the studio.
And that was Jasmine, who's doing her first debut weather report. So hopefully, Jasmine, you'll make a weather presenter.
Stripping down science.
OK, let's do it.
The Naked Scientists.
And if you want to get any questions into us, do get on the phone quickly, because it is getting very, very busy. Let's join Les in Peterborough. Hello, Les.
How you doing, Chris?
Great to have you on the programme. What would you like to talk about?
I've been phoning 3 months, actually.
I did say it was busy on the phones, Les.
No, I know you did. That's all right. It's colour blindness.
Uh-huh.
People say that dogs are colourblind. Right?
Yep.
Is that a fact or fiction?
Well, it depends how you define colourblind, because the version of that urban myth that I've heard is that they see in black and white, a bit like a black and white photograph, and that's just not true. If you look at a dog's retina, the thing that turns light, the stuff that's coming from the sun and the room around you, into neurochemistry, in other words, electrical signals that the nerve cells in the brain can understand, there are structures in the dog's retina called cones, which are identical to the structures in the human retina, called cones, that can see coloured parts of the visual spectrum. So dogs can definitely see colours. But if you analyse those cones, they paint a very different picture of what dogs see of the world than humans do. And in fact, the best way to put this is that dogs are probably what the dog equivalent of the human red-green colourblindness person. So they have a spectrum of cones that means they're pretty good at seeing greens and violets and blues, but at the sort of reddy end of the spectrum, they're less good, and they probably appreciate it as a slightly different colour, maybe a yellow or something like that. But they're certainly not colourblind.
I'm not cutting you off, but she knows sort of yellow, and she knows a red.
Yeah.
Yellow colour and a red colour.
Yeah.
You know, not together, but she knows that. I'm colourblind as well.
Yeah.
I don't know brown from green or anything like that. But
but if you
sorry,
no, if you think how you see the world, which is that there's a problem. In other words, two colours that can be very different to me will almost certainly look the same to you, and that's a really good way of thinking about how your dog sees the world. There will be some colours that you can appreciate, and a bird can. I don't mean a human woman. I mean as in fluttery, feathery thing. A bird, they see the world, and they're very good at seeing colour. Birds have very good colour vision, for various reasons. So we see the world very differently to a dog in terms of our appreciation of the colours. It's a bit like a richer colour environment than a dog would see. And part of the reason for that is that dogs have nocturnal habits. They're normally used to going out at night time, and for that reason they place less emphasis on colour than humans do, because to drive colour vision takes very bright lights. If you go out at night, I defy you to try to tell me what colour something is in the dark. You can't. It's just all one kind of colour. You can only see whitey colours.
Well, actually, you just knocked the nail on the head, because she's a guard dog, and she goes round, and I shine a torch, right?
Yeah.
So does that torchlight mean a yellow to her, or what?
Right. Well, there's another interesting thing here, and you've probably shone the torchlight at the dog's eyes at night and seen them light up in that funny way. Have you seen that?
No, I never do that.
But have you seen the dog's eyes light up in that rather bizarre, kind of bright, ghostly way?
Yeah, I have, actually.
The reason for that is that on the back of a dog's retina they have a structure called a tapetum lucidum. And if you look at dogs and other animals, cats, horses, sheep, pigs, animals that tend to be going around at night time a bit, if you cut their eyeball up, you'll see at the back of the eye, this structure on the back of the eye is very, very shiny. And tapetum lucidum is a Latin word, it means bright carpet. And the reason it's like that is that it reflects light off the back of the eye and shines it back onto the retina to make the eye even better at working in low light conditions, and that's why your dog's eyes do that. But yes, if you shine some light onto the environment, then there's enough light around for the cones that make colour vision work actually to kick into action, and you can appreciate colours. That's true.
Does that actually work with big animals or something? You know, I work. I can't tell you what I work, but does that work with sort of stags? I'm talking about stags and deer. You know, like.
Well, I don't know precisely how they compare with a dog's visual abilities, but I would say they're probably vaguely similar, and therefore, yes, if you illuminate the world, then they'll see things. Their colour vision will work better because the thing is, in the dark, you have to use a different pigment in the retina in order to see. There's a much more sensitive pigment which you use in the rods in your retina. You have about 111 million rods in the average human retina, and the pigment they contain, scotopsin, is really, really sensitive to light, and as soon as it picks up any tiny amounts of light, it fires off. The problem is that in order to make that happen, you connect lots and lots of those rods together, so the actual acuity, how accurate your vision is not so good. But it's still very, very sensitive, and so it's a toss-up between seeing in the dark and seeing very, very well. If you shine some extra light on the situation, you can see much better. We're going to have to move on, though. Do you want to have a quick go at the quiz?
Yeah, go on then.
OK, at the time of the dinosaurs, days on Earth were much shorter and only lasted about 16 hours. Is that fact or fiction?
That's fact.
Yeah, absolutely right. The rotation of our planet is slowing down, so the time it takes for the planet to turn around once, the day, is getting longer, and dinosaurs 65 million years ago only had 16-hour days.
The greatest number of children produced by one mother is 69. Do you think that's fact or fiction, Les?
Oh, my God.
Quite an impressive number, isn't it? 69.
I'm going to go for the outside one. Yeah, fact.
Absolutely true. It was actually a Russian lady called Mrs. Vasilet, and she lived from 1816 to 1872, and she had 69 children from 27 pregnancies. That's 16 pairs of twins, 7 triplets, and 4 sets of quadruplets. So
what a lady. Last question. She's doing very well, actually. If you hold your nose, it's impossible to hum for more than about 3 seconds, and everyone can try this out there. What do you think? Fact or fiction?
That's fact, actually.
Absolutely right. 3 out of 3. With your mouth and nose closed, there's nowhere for the air to go, so the air pressure builds up and stops any more leaving your lungs, so you can't hum, and your head explodes. Or not.
Les, thanks very much. 3 out of 3. And a great question, too.
OK.
Been a pleasure to have you on the programme. Thank you.
OK, thanks to you as well.
The Naked Scientists, it's Kat, Phil and me, Chris Smith, and we're here with you for about another 10 minutes answering any science question on anything. If you'd like to ask us any questions, 08459 25 2000 or email chris@nakedscientist.com.
Fancy listening to The Naked Scientists in your bed, on your way to work, or even at work? Why not subscribe to our podcast? For more information, visit nakedscientist.com/podcast.
Joining us now to talk about an event which is going to happen this week in Cambridge. He's going to be there from the States. Here's Michael Stebbins. Hello, Michael.
Hi, how are you?
Very well, thank you. Now, you've called your talk Sex, Drugs and DNA after this pretty impressive book you've written. Tell us about what exactly you're going to be covering in your talk and why it's so important.
Well, the book itself, the talk's going to be about the book and some of the topics within it. And so I usually leave it up to the audience, who almost always chooses sex to talk about. But it covers embryonic stem cells, global warming, intelligent design, bioterrorism, contraception, drug industry, and healthcare.
So pretty controversial sort of instances of problems then.
Yes, and then juxtapose, and really explains the science behind each one of these things, and then sort of exposes the liars and miscreants who have been pushing policies that are antithetical to what we know about from science.
To what extent is this going to be relevant to people in the UK? Because that's what people around here are going to be asking, Michael. It's great that you're coming to the UK, you're going to tell us about these problems. Intelligent design's probably a bit more of an issue in the US than in the UK, but obviously some of the other things are relevant.
Sure. I'm not so sure that intelligent design is just a U.S. problem. It seems to be spreading, though it is centered in the U.S. at this point. But certainly the other issues that are the issues that are relevant in the U.S. Really do wind up cropping up in the U.K. and Europe, the U.S. winds up being a weather bell for what's going on in Europe to come. So I think a lot of the issues that are controversial, stem cells, for example, are in fact controversial there as well. And the drug industry certainly, most recently, has been quite controversial in the UK.
Well, Michael, look, we're going to really look forward to seeing you at 8 o'clock in Borders Bookstore off of the Market Square in Cambridge. That's on Wednesday the 3rd of May. I think it promises to be quite an interesting lid-lifting exercise.
Yes.
Thanks for dropping in, and we'll see you on Wednesday.
Excellent, thank you.
Laying the facts bare, The Naked Scientists.
It's the Naked Scientists, Chris, Kat and Phil, and if you have a science question for us, might be able to squeeze in one or two very tinsy-wincy ones. Remember that our science experiment tonight, Kitchen Science, was asking you to fill up a wine glass with some water, get it to a certain level, lick your finger, run it round the rim, and then make it make a tune. Pour some water out and do it again. A lot of people have had a go at this, but what was the answer? Well, we're going to go back to Anna, who's now at the King's School, and she's joined by George, Tom and Wendy, and find out the answer. Anna.
Hi there, yes, and welcome back to the King's School in Ely, where we've been doing some experiments with some wine glasses. Hopefully you have at home too. So, in the earlier part of the show, we filled a wine glass with water, and one of our helpers, Tom, ran his finger around the top and made a noise. And then what we asked you to do was to drink half of the water from the glass and play the note again. Now, we're going to find out exactly what happens. So, Tom, can you please make the noise again, please?
Yep.
A beautiful sound, I think you'll agree. And now we want to see what happens to the noise when you pour out some of the water. So do you want to just pour some of that water down the sink then, Tom? Is that about enough, Wendy?
Yep, that should be fine.
OK, so now what we want him to do is to make that noise again, and we want to see how it's different. OK, so, George, you heard the noise before and you heard the noise after we got rid of the water. What happened?
It got higher.
It got higher. Now, actually, I think that's what Tom said. You thought that might happen, but you didn't know why, did you?
No.
So, Wendy, why does running your finger around the top of a wine glass make a sound in the first place?
Well, the important thing here is a force called friction, because, of course, when you rub any two things together, there's a certain element of friction where things stick. Now, you've wetted your finger, so it's made it quite slippy, but there's still a tiny amount of sticking and slipping that's going on as you do that. So each time your finger grips and then slips all of a sudden, it gives a bit of energy to the glass and makes it start to vibrate.
OK, and so what happens then when something vibrates? How does that make a sound?
Well, depending on how much stuff you've got, really, that sort of defines how fast the vibrations will be. Everything of different sizes likes to vibrate at a certain frequency, and that's sort of resonance. Everything has a natural resonance that it likes to vibrate at. And if you take a glass and a certain amount of water, then it wants to vibrate at a certain speed, which gives us a certain note.
So how come when you've got less water in the glass, the note gets higher?
Well, it's quite easy to think about it as something people have probably tried. Like if you have a ruler sticking out over your desk, if you've got a long bit of the ruler and you twang it, it wobbles quite slowly and gives you a kind of low note. And as you make the ruler shorter, it goes faster and gives you a higher note. So when you've got less water, because you've got less stuff, like the short ruler, it's wobbling fast and that gives you a high note.
What would happen if there was no water in the glass?
Oh, good question, Wendy. What would happen?
Good question. It often depends on the glass itself, but it should, in theory, work with no water at all because it's effectively just the glass itself that's vibrating then. But the note would be a lot higher. So if we took all the water out of the glass now, the note would still carry on getting higher.
So, Wendy, I mean, that sounds very similar to me to how if I blow over a milk bottle, for instance, or over a wine bottle, I mean, is that the same principle?
It's a similar experiment, but there's a key difference. So we've got a milk bottle here. Shall I just show you what happens in that case?
Yeah, go for it.
We've got the milk bottle and it's almost full. So to make this vibrate, instead of putting my finger around the bottle top, what I'm going to do, what most people would do when they play this, is blow across the top. So I'll just see if I can get a note.
Okay.
Now I'm going to empty some water out. And remember with the glass, when we took some water away, what happened to the notes?
It got higher.
That's right. So let's see what happens in the bottle.
So, Tom, what happened then?
It got lower.
It got lower. Now, that's the opposite to what happened in the wine glass. That's absolutely insane. Why did that happen?
Yeah, it's a bit sneaky, isn't it? The key difference is the music is being made in a different way, really. When we rub the wine glass, the movement of the glass and the water is what's vibrating, okay? So when we take water away, we've got less stuff and a higher note. With the bottle, instead of touching the bottle, we're blowing across the top. So it's the air that's vibrating this time, not the water and glass.
So when you've gone and poured half the water down the sink, you've actually got more air. So that's like when you have more water in the glass, that the note is also lower.
Exactly. It's the opposite result.
Wow, well, that is absolutely amazing. Well, thanks very much, Wendy. George and Tom, what did you think of the experiment? You first, George.
Yeah, it was interesting.
And Tom, have you done anything like this at school before?
No, not really.
So next time you learn about sound at school, you can be the envy of all your friends by being an absolute super brain. Well, thanks very much, Wendy, Tom and George. And thanks to the King's School in Ely for having us here today. And yes, well, we hope you all enjoyed it at home. And back to the studio. We'll see you next week.
Thanks, Anna. If you'd like to join us next week, Anna's going to be cooking around eggs and playing with eggs and turn them into gyroscopes. So join us for that one. Right, here we have a winner for that, Hannah. Hello, Hannah. She's in Girton. Hi, Hannah.
Hi, Anne.
You did the experiment. What did you find?
Well, I found that it went higher.
Excellent. Well done. You're a winner. Brilliant. Well done for doing the experiment. You've won yourself a copy of Living Science. Thank you for joining in on the programme. Take care.
Bye-bye.
Bye. Right, very quick text message from Kate, who says, love the programme, I'm in Harlow. Repeat how many tonnes of blood the heart pumps in 24 hours. Got to do this very, very quick. Heart pumps about 50 times a minute. It pumps about 5 litres of blood a minute. So if you times that by 60 for the amount of blood in an hour, and then times it by 25 for the number of hours in the day to make the maths easy, it's about 7,500 litres of blood every single day. Blood's about 1 gram per centimetre cubed, which means that that's 1,000 grams per, 1,000 grams per litre. And that means that if you pump 7,500 litres in a day, that's 7.5 tonnes of blood that your heart moves around your body every single day.
Wow, we've got Ben Vaughan in North Carolina. He says, why is it when I pull out my nose hair, do I get a really painful, teary response? Well, for a start, don't pull your nose hair. You should clip it to avoid infections. And it's because your nose is very sensitive, loads of nerves in there. So it's kind of a super nerve reaction when it happens. But yes, don't pluck your nose hair, clip it.
I heard once that Noel Edmonds likes to trim his nose hair. You've been listening to The Naked Scientist. Thank you to everyone that's taken part this evening. I'm sorry if we haven't managed to get through to your questions. Les in Peterborough was our winner, and he's got a copy of Living Science. Next week, we're going to be checking out dinosaurs with Matt Wilkinson and Leslie Noe. But in the meantime, enjoy the rest of your bank holiday, and good night.
Sorting out the sparks from the quarks. The Naked Scientists. For more information, get online at nakedscientists.com.